Alright, so for the first one, what we want to do is we want to make sure we figure out if this is an even function, an odd function, or neither. So we'll start off by substituting in a negative x. What we get from this is we get 2 times negative x, which is negative 2x. What we just figured out is that if we substitute in a negative x, what we get is the opposite of the function that we started with. So we have f of negative x is equal to negative f of x. So if we look at by definition, this is implying or telling us that this is in fact an odd function. Alright, so let's go ahead and take a look at this next one. What we have here is let's go ahead and substitute in a negative x and see what happens. So we have negative x, that quantity squared minus 2. Negative x squared becomes a positive x, and that is x minus x squared minus 2. What they gave us, if you notice, is the original function. So when we substituted in a negative x, what we ended up with is with the original function itself, meaning that this function is even. Alright, so let's go ahead and take a look at this last example here. Let's go ahead and substitute in a negative x. What we end up with is 2 times the quantity negative x squared plus a negative x. Negative x squared gives us 2x. Positive times a negative is a negative x. Then what do you know, if we compare this one with the original function, we notice that there is some difference. Take a look at this difference here. When we substitute negative x, we got a negative number there. The original one is a positive number. It really isn't the positive or the same. So this implies that this is neither odd or even. Okay, now go ahead and try these on your own, and we can compare answers in just a little bit. So go ahead and pause the video at this moment. Again, we're checking to see if these are even or odd functions. So we have to substitute in a negative x to see how it changes. A negative 5 times a negative x, it's a negative 5x. What we notice is that when we substituted a negative number, we ended up, or negative x, we ended up with the opposite of that original function. That implies that this function is odd. Next one, let's go ahead and substitute in a negative x. So we have g of negative x is equal to 2 to the power of negative x. Negative exponent, again, doesn't make the function negative. What it means is we have to write a fraction. So this one here, when we substitute in the negative x, we end up with 1 over 2 to the power of x. This implies that this is neither odd or even. On the next one, we have h of x is equal to 2x squared plus 3. Let's go ahead and substitute a negative x to see what we get. 2 times the negative x quantity squared plus 3. We end up with 2 times negative x squared is just x squared plus 3. So notice that we end up with the same function. It did not change. So that implies that this function is even. And a quick little recap here. Remember what it means to be odd. This means that we need 2 reflections to get back to the original image. This one we can't, the second one we cannot get back after any reflections. And we take a look at this one, this is even. This will take 1 reflection across the y-axis. in order for it to look like the original function. Okay, here we go. And this one, remember when we're graphing these functions, we do have variables a and h, and out here we would have k, but this one's missing. So for this example, what we have is that k is equal to 0, only for this example because it's already missing. Recall that when we were dealing with absolute value functions, if h was greater than 0 before substitution, it was moving h units to the right. And again, and if h is less than 0 before substitution, it was moving h units to the left. Something new for us down here that we might have touched on it very, very briefly is that if you're trying to find the vertex of a function, all you do is you take that h there and you say, well, that's the x coordinate of the vertex. And since k is 0 in this case, we say the vertex is at h comma 0. Now, this here, the symmetry, axis of symmetry, that is the part where if we were to draw in the axis of symmetry where it's symmetric on both sides of the axis of symmetry. If this were 1 unit to the left, it would be 1 unit to the right. It's the axis of symmetry.